Okay, now we're on integration, page 5. So it starts this page kind of where we left off on the last page. It gives us a general rule. If you have something in the form of a times x to the n, then the antiderivative or the integral is equal to ax to the n plus 1 divided by n plus 1 plus the constant c, where c is any number. Okay, so basically what this says is if I have 5x squared, the 5 is the a, and so if I was going to take the antiderivative of this, I would just leave the 5 there, okay? And then the x squared, which is x to the n, I'm just going to increase the value 2 by 1, so I make it into a 3, and then I copy it down below. That's all it says. Okay, so let me give you a more complicated. 14x to the 8th. So if I have this, again, I just leave the 14 there. That's what it says, to leave the a there. And then I take the x exponent, which is 8 in this case, I add 1 to it, and I get 9, and then I just copy the 9 down here. Okay? It's called the power rule. It's the opposite of the power rule that we do in derivatives, right? Remember the power rule for derivatives was if we have 3x to the 5th, that becomes 3 times 5x to the 4th, right? These undo each other. That's why they kind of look similar, except one is reducing powers and the other one is increasing powers. Okay, let's move on. 13H, number 1, find the following indefinite integrals. What does it mean to be an indefinite integral? Notice that these integrals don't have numbers here, limits for lower and upper. So we can just like do the antiderivative, right? Antiderivative or integral, and then we get an expression, and we don't get a number yet because they didn't give us the limits to put in here. Once they give us limits, then we're actually going to be able to calculate a number, which would be the answer, kind of like the way the calculator does it. Okay. So first of all, let's do the antiderivative of 10, or the integral of 10. We're going to say, we're going to use this formula, right? So we take the 10, we set it aside. There's no x there. So you could say that it's x to the 0 if you wanted to. So we would put x to the 1 here. Let me take that step by step. So we're going to take integral of 10x to the 0, which is the same thing as 10, right? Because x to the 0 is 1. We're going to take the integral of this, so we're going to put 10x to the, and then we're going to take the 0 and we're going to increase it by 1, and then we're going to put 1 underneath, and that gives us 10x, right? So we could confirm that. What if you took the derivative of 10x? The derivative of 10x is 10, and then we're like, oh yeah, that works, okay? So the integral of 10 is 10x. All right, now let's do this one. What is the antiderivative or integral of x to the... Oh, by the way, we should put plus c here. Okay? All right, next one, x to the 5th. The antiderivative of x to the 5th, so is there a coefficient? There is a coefficient of 1. We could just ignore it because there's nothing there. And then we're going to take the exponent and we're going to increase it by 1, and then we're going to put it below, right? That's exactly what this expression says to do. And then we just add c. Okay? Now let's do 1 plus 2x. So for 1 plus 2x, it's two things added together. We can do them separately and add the results. So what is the integral or antiderivative of 1? It would be the same thing as how we did the integral or antiderivative of 10. We got 10x, right? So the integral or antiderivative of 1 would be 1x. The integral or antiderivative of 2x would be 2 times x to the 2nd divided by 2, because what I did was I took the x to the 1st, right? This is x to the 1st. I added 1 to it, and then I copied the number down below. I could simplify this. It's plus c, by the way. I can simplify this by saying x plus, and the 2's cancel out, so I get x plus x squared plus c. So that's my answer for that one. Okay, let's look at g. So for g, I'm going to do these three separately, and then I just add the results together. What's the derivative of negative x? It would be negative x squared divided by 2. I treat the negative as a negative 1 times x, so we just leave the negative 1 out front, and then the x to the first becomes x squared divided by 2. Now I'm going to do plus 3/4 x squared. I'm going to leave the 3/4 out front, and then I'm going to take the x squared. I'm going to make that x cubed divided by 3. And then I have plus 0.5. The integral or antiderivative of 0.5 would just be 0.5x. Whenever I have a constant like that, all I do is I add x, or I multiply that times x. And then, of course, plus c. Okay. Now, if I wanted to simplify this, I would just like cancel out these 3's. And I think that's pretty much all I can do. Okay. Next one, the integral or antiderivative of x squared minus 1/2 x plus 4 is equal to x cubed divided by 3. That's the antiderivative of x squared. And then the antiderivative of negative 1/2 x would be, the negative 1/2 just stays here, it's the coefficient. And then I take the integral of x to the first, it would be x squared divided by 2, right? And then plus 4, the integral of plus 4, or the antiderivative of plus 4 would just be plus 4x. And then, of course, I add c at the end. So if I wanted to simplify this, I could just take these two 2's and multiply them together and get x squared divided by 4, right? Okay, here's a tricky one. I'm going to rewrite this first. Remember how whenever we had the derivative of x variables in the denominator, the first thing we did was we rewrote it as a negative exponent? So we're going to do that too. I'm going to put, instead of 2 over x to the 4th, I'm going to put 2x to the negative 4th dx. Okay? So now I'm going to use the same rule, except now we do it on a negative exponent. And so we leave the 2 out front. The x to the negative 4th, we add 1 to it. So instead of negative 4, it becomes x to the negative 3. That's confusing to some people. And then I just put the same number underneath, negative 3. So it's negative 2/3 x to the negative 3 is the answer. And I just add plus c at the end. Okay? Let's see. Next one. Number 2. For f of x equals x squared minus x over 3 plus 4, find the derivative of x. Remember, f dash of x means the derivative, and also find the integral of f. Okay? So remember, especially if we're doing all these integrals, antiderivatives, sometimes we get mixed up and we don't know what we're doing anymore. Go back and look at the formula booklet if you need to. When you find the derivative, you're going to reduce the exponents, and when you're finding the integral, you're going to add to the exponents. So first what I'm going to do is I'm going to take the derivative of this expression here. So the first term, which is x squared, the derivative would be 2x, right? The second term, which is negative 1/3 x, I'm rewriting it as negative 1/3 x, the derivative is simply negative 1/3, right? Because since it's x to the first, the x just kind of disappears. The derivative of plus 4 is plus 0. So basically, we don't even need to write that down, right? So the derivative of x squared minus x over 3 plus 4 is 2x minus 1/3. Now let's do the integral of x squared minus x over 3 plus 4. Okay. So we just take the derivative, or the integrals, antiderivatives of each one of these terms separately, and we just add and subtract them just like they are done here. So the integral of, or antiderivative of x squared becomes x cubed over 3. We added 1 to the 2, and we copied it down below. Negative 1/3 x. So this is negative 1/3 x. So we just leave the negative 1/3 as the coefficient, and x to the first becomes x squared over 2. And then plus 4, the integral or antiderivative of plus 4 is plus 4x, right? And then finally, we just add plus c at the end. Okay? So if we wanted to, we could simplify this. We could multiply the 3 and the 2 together in the denominator, so it would be negative x squared over 6. But we don't have to. Here, on the exam, you would. Okay? All right. Number 3, find the integral of t minus 3t squared dt. And look, instead of having x, like we always have x, this is an example where we have a different variable, t. And it's just that all the x's become t's. So the antiderivative of t to the first, which is just t, is going to be t squared divided by 2. And the antiderivative of negative 3t squared is going to be negative 3, the coefficient just stays there, and then t squared becomes t cubed over 3. And then you can see that like this 3 on top and this 3 on the bottom, they can cancel out, and the answer would just be t cubed. And then finally, we would put plus c at the end, plus c. Okay, so that's the integral of t minus 3t squared. It would be t squared divided by 2 minus t cubed plus c. Okay, last one. Find all the functions capital F for which the gradient equals 3 plus x minus x squared divided by 4. Okay, so what they're asking here is pretty much the exact same thing, but they're using different words, right? And we need to go back and think about, oh yeah, what does gradient mean? What does slope mean relative to calculus? So remember, when we say gradient or slope, we're talking about the derivative. So basically what they're saying is find all the functions capital F for which the derivative equals this function. So if the derivative is this function, that means capital F is the antiderivative. So all they're doing is they're asking us to find the antiderivative of this expression. So the answer would be integral or antiderivative of 3 would be 3x. Integral or antiderivative of x to the first would be x squared divided by 2. And then the integral or antiderivative of negative x squared divided by 4, we're just going to put the negative 1/4 out front. It's a coefficient. We leave it alone. The integral of x squared would be, or antiderivative of x squared would be x cubed. It would be x cubed divided by 3. And then finally, plus c. And if you wanted to, you could multiply the 3 and the 4 together and make it a 12 in the denominator. And now we're done. Okay, so the only thing hard about the last one, or different about the last one, is the fact that they use the word gradient instead of derivative, and then we need to go back to the differentiation chapter and remember, oh yeah, when they say gradient, that means derivative. Okay, so that's it for page 5.